I've got a device here, homemade device, from Professor Chipman's laboratory called Polariscope. Okay, so with the Polariscope, what I have here is a base that is just a fluorescent tube light box, and it's covered with a very large polarizer. And then above it, I've got a second large linear polarizer with large linear polarizer on a kind of a lazy Susan table with bearings, so it rotates. Okay, and then what we're going to do is put objects between the light box and its polarizer underneath, and then this other polarizer that we can rotate above it. Okay, at least if the electrical works for me here. Okay, and I'll move that over. Okay, the first thing I'll show is just the two polarizers. Now, as I rotate the two polarizers, let's do a front view aerial first. Okay, and you can see this is the rotating polarizer, this is the light box, this is the other linear polarizer, and then I'm just going to rotate one with respect to the other. Okay, and now what should I see? I should see a cosine squared, right? Variation in the light power through. Okay, let's look from above then, Ariel. Okay, is there any way you could back out that light a little bit, or that camera magnification? Or is that? Yeah, because it's kind of, there you go. That way it doesn't normalize the light. There you go. Okay, so now you can see it pretty well extinguishes the light when the polarizers are crossed, right? Okay, so here is a linear polarizer. Okay, a little sheet of a linear polarizer. Just go ahead and keep the view this way. Oh, okay, that's kind of cool. All right, so I can take a linear polarizer between the two cross polarizers, and I can transmit a whole lot of light. I'll let you think about that one. Okay, now here's a pair of movie glasses. Okay, ooh, wow, cool. All right, you didn't know this is what you were looking through when you went to see Avatar, did you? Okay, so yeah, question.
Wait, so when you put your hand there when it was completely dark, is that the reflection of like?
Boy, I don't know.
Yeah, was that the reflection of the light from?
Yeah, that's just the light from the overheads. Hey, Ariel, would you mind turning off the lights on the desk lamp, on the desk? I don't know if you can do that, or can I do that? Do you know how to? All right. See, if I just push buttons. Well, okay, good enough. All right. Ooh, man, I don't know. There's something like holy about my hand or something. Okay. All right. All right. So that's a linear polarizer. Here's another one. Okay. This is a red plastic material. I'll hold it out here first. Okay. Red plastic material. Cool. All right. There it is. And I rotate. Not much happens. A little bit. Okay. Now if I flip it over. Ooh. Wait a minute. I didn't think you could have a diode for light. What's that? What's happening there, guys? Okay. It behaves differently depending on how I put it on the device. Another mystery for you to think about. Okay. This very simple device. Oh, I got another demonstration here. This is calcite. Okay. Calcite. I don't know. It's kind of fun. Kind of looks like a polarizer to me. Okay. If you look at stress and strain, this is what it's often used for. These are plastic cups, and then a piece of plastic that's been machined with a hole. Plastic is a polymer that has residual stress in it, so it's pretty easy to see residual stress in materials. Cross polarizers are pretty cool. Okay, and you can see where the machining here actually induced some stress in the plastic domain of the material, which means it doesn't recover, okay, from that. So, they use this to look at plastic lenses that are injection molded, for example, to see what's going on there. Now, depending on the thickness of the material and the dispersion of the plastic, how it was made, you can actually make different wave plates in transmission just by piling up different pieces of cellophane, different thicknesses and orientations of cellophane. Yes?
In the upper left on the screen, there's a hole, it looks like. What is that? Is that just a hole?
Smudge.
Okay.
I don't know what it is. It's not in my lab. So I don't know, somebody could have sneezed with a big hookie on there or something, I don't know. Okay. Anyway, okay, so you can do different things. These examples were made by two of my undergraduate students in my 380A lab class, Soshi Cooper and Paige King. And they made these different designs called, what are they called? It's kind of like a collage, only with polarization. There's actually an artist in California that makes these beautiful things. So when you change the rotation, you get different wavelengths that correspond to the different wave plates according to the thickness of the material and its orientation. So you can do this kind of thing, which is cool. Okay. And I made this one, which is also kind of cool. Isn't that neat? Recognize that? All right. So that's a Polariscope. I think that's just so much fun. Not really quantitative, but it's fun. All right. Any questions about the Polariscope?